I'm Kadambari Devarajan, a PhD candidate at the University of Massachusetts at Amherst. My presentation today is the result of collaborative work done with Prabhu Ramachandran at the Indian Institute of Technology, Bombay. So ecologists employ a multitude of methods to study organisms in the field, from trail cameras to acoustic monitoring tools like recorders and published materials, of course. So the use of these different tools results in a variety of data, and research these days is increasingly generating a large amount of multimedia data, such as photos and videos from camera traps and drones, images, audio files, as well as text files, such as PDFs. So as part of my field research, I often end up with a mountain of multimedia data. For instance, while working on my master's thesis on a guild of carnivores in India, I ended up with over 6,000 videos from my camera trap study that was designed for co-occurring canids, including 2 species of foxes. Each video was 30 seconds long, and entering the data was really arduous, since at that time I couldn't find any existing software that could help me manage such video data. While there were a number of tools to work with camera trap photos, there are several constraints. Some are proprietary or highly restrictive in how the project is set up. Some are available only for certain operating systems, or don't allow for customizing the metadata that we associate with each media file. Some need an internet connection for data entry, which is often a challenge in remote areas. And most importantly, none of them at that time supported videos. So I figured there must be a less error-prone and less time-consuming way to enter such video data without having to toggle between watching the video using one application and a spreadsheet. There was a need for software that checked all these different boxes that would offer support for multiple media types like videos and audio files and PDFs, and that was also freely available and helped and very general purpose and cross-platform, especially supporting multiple ways of adding scripts and extending it. So ViXeN was born to fill this gap as one tool to bind them all. It was designed with the individual field researcher in mind, so it can work in remote areas and is not dependent on internet connectivity. It does not yet support multiple simultaneous users, although there are some workarounds such as partitioning the work. No server or database setup is necessary, and it does not touch the original data, so your data is intact. So ViXeN is very easy to install and is currently offered for Linux, Mac, and Windows. And you can find the installation instructions in our documentation page. Once it's installed, it's easy to launch and opens in your browser. And although the ViXeN user interface opens in the browser, it doesn't really need any internet connectivity. So you can find more information using any of these links, and you can download it from the GitHub repo. So I wanted to briefly do a demo of ViXeN for you. This is how the user interface inside your browser looks like. So when you launch a new project, you can add a bunch of tags that are associated with it. So you first give it a name, and then you describe what the project is, and then you set the path to a directory which contains all your media files. And while I'm setting that up, I can just tell you, once you're done with everything, you can just click on the Stop ViXeN icon here, and to end your save your work and end it. So here we're setting up like I'm pointing the path to the working directory. And then now this is for data on carnivores. So I'm just setting up some carnivores to see if that video had any of these. Say, I can set like maybe 3 species for now. And then if there are any others that I find, I can just add another, like a comment or a note tag. And since I'm just looking for the number of individuals in each video, I can just set the data type for that variable or that tag to integer. And then for the others where I'm listing out the species that I did find but are not really of interest to this particular project, I can just leave it as string. And I can also reorder the how these tags look, and I can remove any if I want to, if I don't need them. And there are a bunch of other things. So one of the important functions is the ability to extend it, and you can add processors, and I'll briefly touch upon that a little later. You can also find more on this in the documentation page. So now that the tags have been set up, we go and view the project. And then this is how the interface looks for viewing it. And you have a list of the directories that are there. These are organized by date, but you don't have to do that. Each project would vary. So once I drill down to the to where the actual media are located, you can click on the video. So this is a combination of images and videos, both of which are viewable within ViXeN. And so you can see the video file crop up, as well as the tags that we had set. And by default, they're, since they're integers, they're set at 0. And there aren't any Indian foxes or desert. None of the carnivores of interest are found here. But what we do see is a desert cat. So what I'm going to do is I will add that to others, that this video has been processed and there was a desert cat that was found. And if I want, I can check on the completed checkbox here, which was set to Boolean, so I know which are the files that I've already seen. So once I save this, I can export it to a CSV file. And so here I'm just giving it a file name. I'm saving it as a test. So this is just so that I can show you how the CSV file looks. The other nice thing is, in addition to exporting it to CSV, I can also import from CSV files. And all I need to do then is to make sure that these tags match the column names in the existing CSV file, and the end have the corresponding data type. So once we've saved that project, we can just, I'll just quickly show you how the CSV file looks. So this is the CSV file for what we just created. It automatically extracts the file name and the file path, and you know, when the camera trap was set up, it automatically extracts that metadata. And in addition, the tags that we had set up are here. Another nice functionality of ViXeN is that it supports complex search. And this is, for example, if I want to find a single fox, I can use this search string within ViXeN, and it'll just show me a list of all the files that have just one fox. And similarly, this would show me all the files that have 2 or more jackals, and so on. And we can just do a quick demo of the search functionality. So I'm showing you an earlier one with a lot more tags. And so I search, that's been processed already. So I just, since desert fox is the name that we had set, it has to match the name of the tags that we had set, basically. So it shows me a list of all videos that from our project that have more than one fox and one jackal. So this makes it very easy to find the ones that are of interest from within ViXeN. We can, of course, also process them separately in the CSV, which would give us anything that we want. If we say import into R or Python or any other programming language for analysis. So this is a set. Now, if I want to see what others, I want to see if I have any videos with hedgehogs in them. So these are a set of. This is how I would search for that, and you can see this video with a hedgehog here. And say if I wanted to look for hair, then this is how I'd go about that. So again, you can follow up on this and learn about other search functionality on the documentation page. So another important application of ViXeN is for literature reviews. And all of us have to do this at some point as researchers. And this is, so if you have hundreds of papers that you have to go through, then ViXeN helps you import or helps you manage such a project. And this is how we would do something like that. We basically do the same thing that we did for the videos, except in this case, the directory will have a bunch of PDFs that are all publications. And then we've set it up already. And so this is how it looks. And you can scroll through. We have now close to 100 PDFs that we're interested in. And so this is how this interface looks for PDFs, and you can do the same thing. And in this particular case, there are like almost 100 tags that are of interest for this project. Another thing you can do is you can replicate or like copy the an existing project so that all the metadata fields are kept intact. And then you can change the path and adopt it if you have a separate project. And you can also remove whatever you really created. So so this shows that there are several powerful features that ViXeN has, and we have some of our future work includes automating extracting the information strip from the camera traps, the one that you see at the bottom, which often contains information like temperature and pressure. So if we can extract that information strip and automate that, that's something that we're working on. And hopefully in the future, maybe offer support for hierarchical tags, because currently that's not supported. So I just wanted to thank a bunch of all the different software that was used in this presentation, and for some of which was used for developing ViXeN, and the organizations that my collaborator and I are affiliated with. So I'll stop there, and I'm happy to take any questions.